Okay, the meeting is recorded.
Yep. Okay. Good morning or good afternoon, everyone. We are on the Friday, Gautam likes to say second or third Friday of the month. We are on the second Friday of the month, and we are having an extra call technically for the working group as part of Phenotype February. So this morning this Friday we're gonna focus on Alzheimer's disease as the first phenotype that we decided to cover as our first week of Phenotype February. We're gonna use this hour to really. Here's our agenda. We're gonna just open it up for maybe 5 to 10 minutes reflection of all the people who have joined for Phenotype February to see if there are questions. I know there are a lot of some confusion about the documents and the tasks. I know we did last week, we discussed the task, but also the core team covered Alzheimer's, so people were like, what we can do. And so there was a confusion. However, lung cancer should have kicked yesterday. And I'm hoping that Anna is on the call to just give a quick update if people have questions for lung cancer or Asia. But we can leave that also for after we finish Alzheimer today. We want to spend the most of the time for today. Patrick going to give a demo of how to use Atlas to replicate. He's going to replicate 3 published definitions of or algorithms for Alzheimer's disease. That he would go use Atlas to show that. Then we're going to spend maybe 25 minutes looking really on few stuff in cohort diagnostics that can give us an idea of how much variation exists among the people who met these 2 or 3 definitions. We're going to focus on 3 definitions in specific because we replicated about 11 definitions from the literature, and it would be really hard to go over the differences among the 11. So we're gonna use the time today to just really do this for 3 definitions so people understand what we can get in terms of what we can look at from cohort diagnostics. Then after the time is over, if people have questions for logistics, we can open it up more. But I would like to take now 5 minutes just to have some reflection, something, anybody having things that they want to talk about Alzheimer or about the steps or the activities, or somebody is like completely confused. So let's make sure that nobody has an urgent need to say something and we don't cover this right now. And before Patrick starts the demo, and then we're gonna move to the demo. I'm opening it up for anybody who have a stressing question or has a point about Alzheimer that we missed, or anything like that. Okay, so then Patrick, you can share your screen and we can hop to the HEPA.
Very good. Let me share my screen real quick. Just confirm that you guys can see that. Yeah, okay, good. All right, so here's what I'm gonna plan to do in under 25 minutes. I guess what Ozzy gave me is I am going to build 3 phenotypes that we identified in the literature in 25 minutes or less. I'm going to walk through all the steps using Atlas to create these phenotypes. Because I'm going to do 3 very quickly, I'm going to be going pretty fast through the tool to orient you all. So I expect that maybe you will have questions. Please post your questions in the chat, and then I'll answer them in the next segment. But what we want to do is just be able to run through a series of these phenotypes. So I'll tell you what the phenotype was that we identified, and then I will actually just proceed to build it and show you various tips and tricks you can use in Atlas for building phenotypes. All right, so timer starts now. So the first phenotypes we're actually going to build are from the Chronic Conditions Data Warehouse. This is something that in the US, Medicare uses for some of their research. Effectively, what they've done is they've defined a collection of different diseases, and they've got multiple versions of this. The first version going back was what they refer to as the 27 CCW chronic diseases, of which this was during the duration of time that captured both ICD-9 CM codes that were used in the US prior to October 2015, as well as ICD-10 CM codes used after October 2015. And across all of these conditions, there were in fact two definitions that were relevant to us: Alzheimer's disease and related disorders, or senile dementia. As I mentioned, we started with a literature review, so one might be asking, why am I going to this random website? But it's actually because one of our papers that we identified, McCarthy, specifically was using the CCW27 chronic disease definition as their canonical reference definition. And when I went down to follow the literature, that led me to this definition, which is the 27 CCW chronic condition algorithm, which effectively says Alzheimer's disease is defined by a diagnosis code in any position of any inpatient or outpatient medical claim using one of the following codes. And they provide a list of ICD-10 codes and an ICD-9 code. Now, as it happened to be, when I went down to follow the literature, it just talked about the CCW definition, which was here. And then when I got to this website, I said, hey, wait, there's now a new 30 CCW definition for Alzheimer's disease. And so I was like, I wonder what the difference is there. And that algorithm only provides ICD-10 codes. It ends up being the same exact set of codes, but they changed the algorithm to require one inpatient claim or two other types of claims. And so here we have an example of one institution creating two algorithms for the same clinical idea, using the same diagnosis codes, but changing the logic, with the first logic simply being an occurrence of a diagnosis, and the second one being requiring one inpatient or two outpatient codes.
Patrick,
so the first two algorithms I'm going to create are going to be both of these.
What's the reference period? Because it changed as well, 2 and 3.
Yeah, so the
clean window.
In this context, they talk about reference period. What they are actually specifically, when you see up here in this reference period, what they're really talking about is if you are going to do something like compute a prevalence, how long back you're going to look for these things. It's actually not intrinsic to the algorithm itself in terms of how they're doing that. Okay, so those are going to be our first two definitions. I'm going to jump into Atlas. I'm going to, I know that some of you have varying different skills in Atlas, but I'm going to walk through how I would build these cohort definitions, just so you can kind of see me go through the process. So the first things first is that I look at this 27 CCW, I see these various codes, and I want to know how these codes are going to show up in the literature. So I'm going to start by just grabbing this ICD-9 code of 331.0. I'm just copying that, and I'm going to search the vocabulary for that particular code. When I'm doing that search, it's going to identify any different vocabulary of any sort that has that, but I'm looking specifically for the ICD-9 CM code of Alzheimer's disease, and I can see it's there, and I can see that we have lots of record counts in the OHDSI network. If I click on this particular concept, so this is a non-standard concept because it doesn't map into one of our standard vocabularies, but I can follow the related concepts to see where does it map into SNOMED being our standard referent vocabulary. And I can see here that the code ICD-9 of 331.0 maps to a standard concept of Alzheimer's disease, which sounds pretty good. So I'm going to select that, and down here I'm going to say I want Alzheimer's disease, and I'll take any of its descendants, and I'm going to add that to a new concept set. I'll click over on the concept set, and I'm going to name this the 27 CCW Alzheimer's disease concept set. And now that I've created this thing, it's quite simple, Alzheimer's plus descendants, I can look to see what are the included concepts. I'll sort on the record counts to see which things actually show up the most. And across the OHDSI network here, we can see that Alzheimer's disease, that's the concept that actually shows up. But there's tremendous value in us using the descendants, because we can see there are actually 38 different concepts that are subsumed by Alzheimer's disease and primary degenerative dementia of Alzheimer's type senile onset, and primary degenerative disease, dementia of Alzheimer's disease pre-senile onset. Both of these also have millions of records across our network, so it's good to be able to pull these things in. What I can also do is go look at the included source codes, because as I've now added a standard concept, I might want to make sure that I can verify I can produce the same concept set that I started with. So a reminder here, ICD-9, there's only one code that was listed, and I can verify that this new concept set only pulls in one code. But we can also see from the CCW definition that there's a series of G30 codes, G30.0, 0.1, 0.8, 0.9. And so now I need to verify whether my concept set includes those concepts so that I'm faithfully representing this idea. So to do that, I can simply change the source vocabulary that I'm looking at source mappings to. And indeed, I can actually see that if I just look from the perspective of an ICD-10 CM code, I indeed pull in G30.0, 0.1, 0.8, and 0.9, just like the CCW definition. So effectively, by searching for the one ICD code, mapping up to the standard, looking at the descendants, in this particular case, I'm able to pull in the exact concept set that subsumes our CCW27 definition. And because the CCW30 definition uses the same codes, I now have one concept set that's going to work nicely for both of those. So now I needed to be able to define the logic. To do that, I'm going to create a new cohort definition. My first definition is going to be CCW27 Alzheimer's disease. And in this particular case, all we needed was a single occurrence of a diagnosis code. So diagnoses are found in our, so I'm going to look for an entry event, and diagnoses are found in the condition domain. So I will add a condition occurrence, and I will simply select the concept set I just created to 27 CCW Alzheimer's disease. And at this point, I have actually fully replicated the CCW27 definition, because all it required was an occurrence of this code. We've now filled in something that's implicitly defined, which is that we are saying that the entry event is the moment that the first diagnosis occurs. And we're also filling in implicitly the idea that a person who has Alzheimer's disease has Alzheimer's disease for the rest of their medical history, represented by the cohort N being the end of observation. So this logic is fully congruent with this particular definition that we've got from the CCW definition, matching the codes and matching the idea of a condition occurrence, a claim occurrence in any position. So with that definition in place, we know that the only difference between the CCW27 and the CCW30 is this requirement that we have either one inpatient code or multiple codes. And so to do that, I'm going to copy this cohort definition. I'm going to just change its name to CCW30. And I'm now going to start to build logic for this. In this particular case, we already have our entry event, which we know that someone could qualify if they had an Alzheimer's disease. And so now I'm going to add an inclusion criteria. And my inclusion criteria is going to be that either the diagnosis occurred during an inpatient visit, or the person has two or more diagnoses. So to implement that logic, I am going to go here to our inclusion criteria. I'm going to select a requirement of a visit occurrence. My visit is going to be looking for an inpatient visit. So I've got just a concept set that captures our OHDSI definition of an inpatient or an inpatient ER visit. And I'm simply going to require that the inpatient visit start sometime on or before the diagnosis and end sometime on or after the diagnosis. That's going to cover our first part of the criteria. But I've got an or statement here, so I'm going to change this to any, and I'm going to now add an additional requirement that says, or they have to have another condition occurrence of Alzheimer's disease, and I'm simply going to require that it happens anytime after the index diagnosis. By this definition, I now am saying I'll go find the first time someone has a disease, and if that record occurs on an inpatient visit, then it's going to count. Or if after that date they have a secondary visit, it's going to count. In either case, we're going to index on the diagnosis code, and we're going to presume that the person has Alzheimer's disease for the entire duration of their medical history. So in this particular case, I've just walked through a relatively straightforward way to faithfully implement both the CCW27 and the CCW30. How am I doing on time? That was about 8 minutes. Okay, so I got 10 minutes left to do our third definition, and this one's going to be purposely more complicated. I'm going to actually use this paper that we identified in our literature review by Harris et al. In the Journal of Alzheimer's Disease, and it's the impact of routine vaccinations on Alzheimer's disease. And in this definition, they were using Alzheimer's disease as an outcome for their estimation study. And if I scroll down in the manuscript, we're going to read the description of how it was defined to be implemented. It says that we identified patients as having Alzheimer's disease if they met any of the following 3 criteria within a 12-month window during the follow-up period. Either they must have 2 or more diagnoses of Alzheimer's disease, or they must have 1 or more diagnoses and 1 or more prescription records for Alzheimer's disease-related medications, or they must have 2 or more prescription records for Alzheimer's disease medications. They specifically highlight that a person who has only 1 record of Alzheimer's disease or only 1 drug, they're not included. And they specifically say the ICD-9 codes and the list of medications is available in the supplemental material. So I'm going to flip over the supplemental material just so you can see that. And indeed, they provide a nice listing here. The Alzheimer's disease medications that they are interested in are donepezil, galantamine, this drug, and memantine. So those are going to be our 4 drugs that we're interested in. And their diagnosis codes for incident Alzheimer's disease case detection are the following. Now, here is where this list of codes is not just a list of codes, but rather, as you can see written, they do what is a common simplification thing, which is to put an X to represent a wild card, meaning that you've got to somehow know what all the codes are that somehow fall under this particular hierarchy. So in this particular case, what we now know is that the logic that we're going to try to build is going to require creating a new concept set for these diagnoses, because this is not the same thing we just did. And we're going to have to create a concept set for these drugs. And we're going to have to come up with some sort of logic that says 2 diagnoses, 2 drugs, or at least 1 drug and at least 1 diagnosis. So first thing I'm going to do is walk through the vocabulary thing. And I see Andy's on the call, and he had asked this specific question about how do we actually go through and go chase after these codes, follow the vocabulary, and make sure we don't pull in everything else. So I'm going to just walk through the step of how I did that in this particular case. So here, what I'm going to do is I'm just going to grab this entire string of all of these ICD codes, even though there's some with X's. I'm going to go into the concepts. I'm going to create a new concept set. So I'm going to close this one out. We're going to create a new one. I should say also, I'm using the Atlas demo environment. This will be publicly available, and we'll also save these JSONs in our Phenotype February experience here so that everybody can have them without worry that they get changed in this demo environment. So this is going to be Alzheimer's disease according to Harris, JAD 2023. And so here what I'm going to do is I'm going to actually import source codes. I'm going to remove those X's because, of course, those X's are not actually telling us a code, rather some sort of placeholder. But this is going to give me a set of ICD-9 codes that I can look for. When I search for those concepts, I can restrict myself to the ICD-9 codes, and I can see that it found all of those 4-digit codes anyway in the vocabulary. I'm going to just simply select those and add them to my concept set. Now, at this point, what I have is a whole collection of non-specific, non-standard source codes. But what I want to do is be able to translate these things into standard concepts. And so the way that I can do that is I can actually just click on these one by one. I can click on senile dementia. I noticed again that it's a non-standard concept. I can follow its related concept, and I can see that the source code of senile dementia uncomplicated maps directly with a 1-to-1 relationship to uncomplicated senile dementia. Now I can just click on this concept and add it directly to my concept set if I'm interested. In this particular case, I see that I saw uncomplicated concepts. I might just be interested in how does this thing organizationally roll up in SNOMED. So I can look at the SNOMED hierarchy in this particular case. And we can see that, for example, uncomplicated senile dementia rolls up to senile dementia. If I were to even click on senile dementia, I could follow that hierarchy. You see senile dementia rolls up to dementia. And so this just gives me a general understanding and navigation of what's in the SNOMED hierarchy and what may be related. I can also see these various record counts to try to follow this. So if senile dementia was something I want, I could simply click this, select the descendants, and add that to my concept set. I'm just going to follow that procedure a few times. So here I've selected senile dementia. I'm going to say, well, I've captured those right there. So I'll remove those. I'll ask the question about senile degeneration of brain. I'll do a similar trick. I see that it maps straight to senile degeneration of brain, so I'll add that to my concept set. I'll remove that because I've caught it. I see that there's something called...
You didn't click descendants. Did you need to click descendants?
I didn't click descendants. I'll go click descendants, and we'll use that as an example. In this particular case, I see pre-senile dementia. So to Kevin's point, I may be interested in saying I want that plus its descendants. So I'll go ahead and add that. Let's see, where did I miss? So in this particular case, I didn't pick descendants, so I can make the determination about whether or not I wanted descendants on that. We'll say that it's okay for now. I'm going to remove this one. And then to Kevin's point, and to underscore this, we now see this particular code, dementia unspecified. So somehow we want to grab this particular code. And dementia unspecified, we can ask where does it roll up to? And we can see that it rolls up to the concept of dementia. Now, dementia, we can see has a pretty large record count, but also a huge descendant record count. And so I may have to ask the question, if I take dementia plus its descendants, am I going to be pulling in things that I don't particularly want, which is the concern that Andy raised on Tuesday. So what I can do to explore that for this particular concept is I can just select dementia, and I can ask the question, what are the specific source codes that map directly into dementia, and what things map into descendants of dementia? And to do that, I'm going to go to the Related Concepts tab, and I'm going to be able to see, first I'll just say, what are all the source codes that map directly into dementia? And I'll look at ICD-9, and we can see that it is 290, 294.2. Happens that those are the things that we want, so we're happy with that. I can also look to see the corresponding ICD-10 codes that map in there, F03 and F03.9. That's great. Those are the things that the code actually wanted. I can also ask the question, though, maybe I'm interested in taking the entire set of descendants, so I could take anything that's a descendant. And if I do that, we can see that there are a very large set of source codes that map to a descendant of dementia, including a lot of the different codes that are those related dementias that are not part of the Alzheimer's disease. So this is a way for you to be able to investigate, decide if I'm dealing with dementia as my concept, do I want to click this descendant concept or not? And in this particular case, I know I want the concept, but I don't want its descendants because that will sweep in other codes that I'm not familiar with. So I've got dementia. Do a similar exercise here for cerebral degeneration. We can see here, it's only a small number of things directly mapped to that, but a huge number of things mapped to descendants. So I know that I just want that particular concept. I'll remove that one. And then Alzheimer's disease, this is that same code we started with the 27 CCW, and we know that we like that plus its descendants. So now I've just transformed the ICD-9 codes into a set of standards, but I need to verify that I now have brought back exactly the codes that we started with. So I will go to the included source codes. I will check the ICD-9 listing, and we're going to see here that now we have 290.1, 210.2, including some 5-digit codes. We've got 294.2, 331.0, 2, 8, and 9, which you can look over here. This is the set of codes that we're talking about, including those descendants. Now, to Andy's question earlier, we are going to see that we also, draw your attention here, 331.0.2 and 0.9. We're going to see that to do this, we don't have an exact match because we've actually had to pull in 331.8 and 0.89. And 0.89 would be the one. Why did this happen? Because when we pulled in cerebral degeneration unspecified, that mapped to cerebral degeneration, and so does the unspecific code of other cerebral degeneration. So in this particular case, by using standardization, there is a vocabulary distortion that occurs, which is this particular code, and you need to be cognizant of that. If you really were only working on ICD-9 codes, you could just remove that code. If we're creating a standard definition, we need to think about the clinical logic about what's happening here. And in this particular case, when we're dealing with a lot of other and unspecified codes, you will occasionally see these examples where you either are choosing to take other and unspecified stuff, in which case very often ICD code list may not contain everything, or you're going to say we don't want other unspecified stuff because we don't know what it was, in which case you'd be losing one of the particular codes. Now that was the ICD-9 world, and that was the thing that I started with, but I also need to be able to verify the ICD-10-CM world. In this particular paper, they listed F03.9 and then G30, G31, and G31.9. And here we can see by looking at ICD-10, we've got F03, G30, G31, G31.83. That's something we don't want, and we're missing G31.9. So given that we actually just pulled in something we don't want, what we can do is we can click on that and say, geez, how can I remove that? In this particular case, remember we selected senile dementia and its descendants. One of the descendants was senile dementia of the Lewy body type, which is something we want to exclude. So I can simply select that and exclude it from my concept set. When I do that, I will now preserve all the senile dementias, but in my ICD-10 code list, we'll now see that I've removed the one extra code that I inadvertently swept in. But I'm still missing a code, which is G31.9. So I'm going to do a search on G31.9. I'm basically searching for that ICD-10-CM code, which is right here. And I'll do the same exercise of following it into the vocabulary. We can see that it maps both to degenerative disorder and disorder of the nervous system. Both of those sound scary broad to me. I'm worried about selecting them, so I'm going to need to investigate it. So I'll select degenerative disorder, worried that that sounds way too broad. And I'll ask the question, what are the ICD-10-CM codes that map to degenerative disorder? Sounds way too broad, not really liking it, but I need to verify what the vocabulary is going to do with this. And so I can select the standard to non-standard code and look at ICD-10-CM, and sure enough, learn that the only ICD-10-CM code that maps to degenerative disorder is degenerative disorder of nervous system, unspecified, plus this non-billing code. So even though I wouldn't have on the surface, based on the words alone, been very comfortable with taking degenerative disorder, I now know I can pick this and pull in that one particular code that happened to be in that paper if my goal is just trying to faithfully represent that algorithm. And so now I have created a concept set, Alzheimer's disease according to Harris JAD 2023, that contains all of the ICD-9 codes, all of the ICD-10, let me go through it again. All of the ICD-9 codes that they wanted, with the note that we've also swept in 331.89, and all of the ICD-10 codes. And this ICD-10 code list actually is a verbatim match of exactly what they wanted in the particular code. Now, I am doing this for the purposes of replicating this paper. I am not drawing judgment about whether this is a good thing or a bad thing. Very concretely, if I did impose my judgment, I'd say that it's crazy to say you do want 331.9 and you don't want 331.89. But nonetheless, that's what they did. And so I'm just pointing out that this is different from the replication. So now I've created a concept set. That was like the harder part. The other thing you'll remember we needed to do was find these 4 drugs. So I'm simply going to search for dinezapril here. I'm going to search the vocabulary for that particular ingredient. We've got 4 of them to find, but I'm going to use the vocabulary hierarchy to be able to help me find this. So first things first, I want to find dinezapril. I can see there's an RX norm ingredient for that. And so I'm going to go ahead and select that one. But we know that these are all drugs for Alzheimer's disease. So I'm hoping that somehow if I follow the hierarchy, I can see that dinezapril is an anticholinergic. I'm sorry. And if I follow that, we can see that that is an anti-dementia drug. So I'm going to click on anti-dementia drugs, hoping that this ATC classification might help me identify all of the ingredients that I might be interested in. And in this particular case, if I limit myself to ingredients, I can see that I can find dinezapril, memantine are 4 drugs, and I can also take note of the fact that there are other drugs, according to the ATC hierarchy, that could be used for Alzheimer's or for dementia, but were not included. I highlight this specifically because this drug, Tacrin, was in fact listed as in one of our other papers that we found, but not listed in this paper. But in this case, since we're trying to faithfully represent Harris, I'm taking those 4 drugs, I'm making a concept set, and this is AD drugs according to Harris, JAD 2023. Sorry, Gaza, I'm 3 minutes late, but I promise I'll finish soon. Now that we did the hard part of creating the concept sets, all I need to do is build a cohort definition. Recall that our definition is 2 diagnoses, or 1 diagnosis and 1 drug, or 2 drugs. So we simply need to be able to come up with a way to build the logic to represent that. This is going to be Alzheimer's disease according to Harris, JAD 2013. So given that logic, there's 2 possible ways I could enter the cohort. I could either enter it according to one of those diagnosis codes, or I could enter it according to a drug. So I am selecting 2 different domains. I'm selecting the diagnoses and the drugs. And now I've basically said, let's say that I could enter on any possible occurrence of one of these diagnosis codes or this drug codes. I'm selecting all occurrence because I still have this extra requirement based on the paper, if you recall, which says that I need to see that second code or that the second occurrence of something in a 12-month window. So I'm selecting all occurrences, and now I'm going to add an inclusion criteria, which is going to be that I either have 2 diagnosis codes, or I have 2 prescriptions, or I have 1 diagnosis and 1 prescription. Now, there's multiple ways we can model this in Atlas, but I'm going to take a very simple Boolean logic, straightforward thing, which is that if I know that I'm entering on either a condition or a drug, then by the basis of this, that the logic is actually that I just need to have 1 DX or 1 RX anytime after. And the reason for that is if I come in for a condition, then if I have either a drug or a condition later, I'm in. If I start with a drug and I have either a condition or a drug, I'm in. In either case, this logic will allow for us to capture that, at least in my reading of this clinical definition. Now, so what I would need to do is say that there is an occurrence of a condition at least 1 day after, or an occurrence of a drug 1 day after. And this logic specifically here is going to provide me the ability to find all people who have an earliest time whereby they have a condition followed by another condition or a drug, or they have a drug followed by a condition or a drug. What's not explicitly stated in this paper, but I'm going to highlight it, is this statement simply says 1 diagnosis and 1 prescription. It does not provide temporal logic that says that the drug has to come after the disease. Had it said that, I would have had to change this logic. Now, the last thing I'm going to highlight is now that I've done this, the paper highlighted that this is in a 12-month period. The paper is quite ambiguous about what this 12-month period represents, but I'm just going to infer that we need to see these 2 occurrences inside of 12 months. So rather than looking all time in the future, I'm going to look 365 days in the future. That gives me my 12-month period of time to qualify. The consequence of this is a given person could have a diagnosis, then 5 years later have a diagnosis and a treatment, and we're going to index on that event that happens 5 years later, not on the earliest ever diagnosis. So with that, we have just implemented 3 algorithms going in ranging complexity, both in terms of their concept sets and logic. And what Aza and Anna are going to do is talk about how we can use cohort diagnostics to evaluate those definitions. If you guys have questions for me about the demo in the chat, I will be happy to answer questions as we're going along.
Okay, you did it. That was amazing. Okay.
Hey, Aza,
So,
I'm just gonna pause. I'm gonna stop the recording and then restart it.